Hi, Ma'am Sir. This is our research entitled Hand Sanitizer and Non-Contact Temperature Measurement, prepared by Elias Sonchon, Peter Jan Gutierrez, Laris Babiera, Jador Vallejo, and Jomal Bautista. Chapter 1: Rationale of the study. To help avoid the spread of coronavirus disease 19 or COVID-19, this research aims to create a machine that automatically dispenses hand sanitizer and measures body temperature. The machine utilizes an open-source Arduino-based platform in order to be programmed to control the system of dispensing the hand sanitizer and measure temperature. For the hand sanitizer, a proximity sensor is used to detect nearby objects without any physical contact. On the other hand, an infrared or IR sensor module is used to measure the heat of an object as well as to detect the motion. The machine eliminates the frequent use of a handle to prevent physical contact and further transmissions of the disease. Next, introduction. In this study entitled Automatic Hand Sanitizer Dispenser with Non-Contact Temperature Measurement is an experimental research to create a machine that will eliminate bacteria, disinfect objects that has been contaminated with infection diseases or viruses, and especially to help avoid the spread of coronavirus, also known as COVID-19. Now this day, the demand of hand sanitizer has increased as coronavirus broke out and spread throughout the world. Hand sanitizer usually applied by squeezing the sanitizer liquid, also known as alcohol or isopropyl alcohol, out of its container. This causes people to come in contact with the sanitizer handle, which increases the transmission of virus or bacteria. Moreover, each person presses the container and increases the possibility of contact to the person, which possibly carrying the viruses. For this reason, by creating this machine, the actual contact to the sanitizer container will reduce, and also by applying the non-contact temperature measurement, also known as thermal infrared sensor, will help to monitor the body temperature of the people, which help to avoid the spread of the virus. Next, statement of the problem. COVID-19 has been significantly increasing over this past month. Consequently, demand for this disinfectant and disinfectant tools rises at the same time. Specifically, demand for hand sanitizer has been surged since the coronavirus broke out and spread around the country. Typical hand sanitizer needs to be pumped by use of palm use may lead to people come into contact with the pump handle that may increase the risk of transmission. Therefore, automatic hand sanitizer was designed in order to prevent transmissions of viruses and being sanitized without having a risk of being infected. Furthermore, it can be operated compatibly despite of huge masses in a public place because of its uncomplicated and much easier to use. Moreover, this device can still be used despite of disinfectant liquid is already low by refilling it. Users do not need to refill case container for the liquid disinfectant. Thus, it is economically and eco-friendly by decreasing waste emission. This automated hand sanitizer will be greatly benefited to everyone that uses it, especially people in the public places, market, restaurant, and place with the masses of people because of its contactless and hand disinfections and having much easier access to the device. Objectives. The objective of this research is to create an automatic hand sanitizer dispenser with non-contact temperature measurement system that will be used for sanitizing and measuring body temperature simultaneously. Especially this study aiming to attain the following. Specific objective. Number 1 is user-friendly, cost-effective, to create a device that will eliminate harmful organisms like virus, to help establishments like hospital, pharmacies, malls, etc. to monitor the body temperature and sanitize the people who is entering and leaving the establishment, to make the Philippines COVID-free, to help the people avoid any harmful organism like virus. Significance of the study. This study entitled Automatic Hand Sanitizer Dispenser and non-contact temperature measurement is an experimental research that focuses on designing, modeling, programming, and creating a device that will help people prevent infectious diseases and viruses and also for monitoring body temperature. Moreover, the result of this study will benefit the following. The people. The result of this study will help the people in the Philippines to be aware about the value of the hand sanitizer, especially now pandemic. This way, they can avoid being infected by any harmful organism like coronavirus. Healthcare practitioner. The result of this study will help the healthcare practitioner sanitize and monitor the body temperature of people who's entering and leaving the hospital, and also they can always sanitize their hand before and after meeting the patients. Establishments like pharmacies, malls, and public places. This study will help the establishment like pharmacies, malls, and public places to disinfect the people who is entering and leaving the establishment to avoid the spread of any harmful organism like virus, especially COVID-19. Last is the economy. The result of this study will help the economy to go back to its normal condition because researchers found that not only humans, pharmacies, malls, restaurants, and etc. should give preservations and importance to this pandemic, but also we should know that the economy is in the line that we keep. Scope and limitation. This study focused on the modeling, designing, programming, and creating an automatic hand sanitizer dispenser with non-contact temperature measurement. The automatic hand sanitizer system design will be presented in three stages: the instrument structure, control design, and hardware design. Instrument structure is the actual planning, technical drafting, and modeling of the hand sanitizer system by using SolidWorks, AutoCAD, or other 3D modeling softwares. This way, the researcher will determine the actual measurement, the length, width, and height of the device, and also the appearance of the final output. Control design is the actual programming to control the system of the hand sanitizer dispenser by using Arduino or the IDE or the programming softwares. Lastly, the hardware design is the actual applications to the previous two stages: instrument, structure, and control design. It is the stage that we will put all the parts together and create a functioning machine. The researcher working on this study to find out if automatic hand sanitizer dispenser and non-contact temperature measurement is a device that will help to prevent any harmful organism like viruses, especially the COVID-19. This study focuses on the creations of the machine and also to make all parts of the machine work together and how it will benefit others. Next is the location of the study. Due to a rising number of people infected by COVID-19, the researcher study will be conducted through online to protect the researcher and to prevent the spread of coronavirus and other infections. The researcher will have different tasks to fulfill via online strategies as mean to follow the advice provided by local health authority or our health protocol by the government, such as social gatherings and social activities are interdicted. Chapter 2. Review of Related Literature or RRL. In this pandemic, alcohol-based sanitizer are commonly used as sanitizing agent for prevent infections and kill bacteria, fungi, and viruses. According to the article entitled Hand Sanitizer of COVID-19, How is COVID-19 Impacting the Demand in the Alcohol-Based Hand Sanitizer Market? It stated that the market landscape of hand hygiene products has drastically changed since the outbreak of COVID-19. The average market demand across the globe is likely to witness a phenomenal rise over 600% during 2020. It means that when COVID-19 spread throughout the globe, the average demand of hand sanitizer drastically increased by 600% globally during 2020. Alcohol-based sanitizer are the major contributors to the global sanitizers market, and there are two types of alcohol-based hand sanitizer. Number one is ethyl alcohol and isopropyl alcohol. The ethyl-based sanitizer segment has witnessed tremendous growth since the impact of COVID-19 pandemic. The growth opportunities can be attributed to the fact that these ethyl-based sanitizers are 40% more effective against viruses than normal sanitizer. Isopropyl alcohol or 2-propanol, also known as isopropanol or RPA, is the most widely applied sanitizing agent in pharma, hospitals, clean rooms, and devices or surgical equipment. Since the coronavirus infections has rapidly increases globally, the sanitation products have become mandatory for the healthcare practitioner. Chapter 3: Methodology. The main objective of this study is to develop an automatic hand sanitizer dispenser with non-contact temperature measurement that will be able to reduce the spread of viruses such as COVID-19 and save people from a pandemic. The dispenser device was fabricated under two key objectives: user-friendly and cost-effective. The materials to be used in the device fabrication were selected and actuated with these goals in mind. A brief information of the hardware components together with their key feature is presented in Table 1. Furthermore, an overview of fabrication process of the dispenser device is shown by a flow chart in Picture 1. So, the material needed is number 1, Arduino Uno. The Arduino Uno is an open-source microcontroller board based on microchip Atmega 328P microcontroller and developed by Arduino.cc. The board is equipped with sets of digital and analog input and output, or the I/O, pins that may be interfaced the various expansion boards or shields and other circuits. And their specifications rate voltage being 3.3 volts, 5 volts ground. Resets the microcontroller, input or output pins, digital pins 0 to 13, analog pins AO to A5, PWM 356911. The cost 249.75 pesos. Next one is proximity sensor. IR proximity sensor is a simple infrared sensor which is used to detect the obstacles. This is an active infrared sensor. It emits and detects its own IR rays. A passive infrared sensor only detects the emitted IR rays from objects. PIR sensor is a good example for passive IR sensors. Their specifications at maximum operations distance 2.5 mm or 0.98 inch positive negative 20%. Stable sensing range 0 to 1.8 mm 0 to 0.71 inch. Standard sensing object iron sheet 15 by 15 by 11 mm or 0.591 times 0.591 times 0.03 inch. Supply voltage 12 to 24 volts, DC positive negative 10% ripple, P+P 10% or less. Output non-contact DC two-wire type. Load current 3 to 70 mA. Note 5. Residual voltage is 3 voltage or less. Note 6. The cost 89.80 pesos. Next is the water pump, used to pump out any fluid in or out of its container. Their specifications: rated voltage 12 volts DC, max rated current is 350 mA, max flow rate is 240 liter per hour, max head or lift height is equal to 3 meter, submersible installations and entirely waterproof. Cost 328.46 pesos. Next is infrared temperature sensor. The LM35 temperature sensor gives output depends on pouring heat over the sensor device. but you can't get into fire to detect accurate temperature value. This MLX9061 sensor gives non-contact temperature sensing. Their specifications, factory calibrated in wide temperature range to -40 to 125 degrees Celsius for sensor temperature and -70 to 380 degrees Celsius for object temperature. The cost 406 pesos. Next is I2C LCD. An I2C LCD has only 4 pins that interface it to the outside world. The connections are as follows. The ground is the ground pin and should be connected to the ground of Arduino. VCC supplies power to the module and LCD. Connect it to the 5 volts output of the Arduino or a separate power supply. Their specifications compatible with Arduino or Genuino Uno, Leonardo, Mega 101 Intel Core, and Micro, Nano, Mini, and Mini. 12C address 0x20 0x27 or 0x20 default. Backlit or blue with white char color. Supply voltage 5 volts. Interface I2C /TW1/1. Gadgeter interface ×2. Adjustable contrast size 80 by 36 by 20 millimeter or 3.1 times 1.4 times 0.7 inch. The cost is 106 pesos. This is the potentiometer. A potentiometer is a simple knob that provides a variable resistance, which can read into the Arduino board as an analog value. Their specification is 0 to 10, then 23 in maximum third. Cost 20 pesos. Next is the methods. The automatic hand sanitizer dispenser and non-contact temperature measurement will be presented in 3 stages: instrument structure, control design, and hardware design. This work focuses on controlling the water pump's strength capacity, the infrared thermometers, range capacity, and also the accessibility of the device. This one is the concept of instrument structure, design, and modeling. The performance of any device relies on different factors, such as durability, the endurance of the device in environmental changes. The factor mostly depends on the design and architectural structure of the device. The automatic hand sanitizer dispenser was designed using SolidWorks, and as you can see in page 2, the structure of the automatic hand sanitizer dispenser and also its measuring units are shown in table 2. As you can see in picture 2, the structure of the device is measured in centimeters. The acrylic glass sheet will be used as structure framework of the device and sterilized with non-toxic and non-pyrogenic ethyl alcohol. The device will operate by a DC brushless water pump and also used for pumping out the sanitizing liquid out of its container, and the measurement or the diameter of the nozzle is 3 or 2 millimeter or 0.3 or 0.2 centimeter. The overview measurements of the hand sanitizer dispenser and non-contact temperature measurement has an overall dimension of 30.48 cm by 22.86 cm by 35.56 cm. Table 2. Design parameters of the automatic hand sanitizer dispenser and non-contact temperature measurement. As you can see on the table, we have measuring quantity for measurement and centimeter and inches. The length is 30.14 centimeter or 12 inch. The width is 22.86 cm or 9 inch. The height is 5.56 cm or 2.3 inch. Base plate height 7.63 cm or 3 inch. Sidewall 6.35 cm or 2.5 inch. Next is the control design, controlling the system. As you saw in the figure 3, the automatic hand sanitizer is composed of 7 components: the battery source, relay, DC brushless, water pump, potentiometer, IR proximity sensor, breadboard, and Arduino Uno. The power supply provides voltage and current for the operations of the motor and board, and its power source is in battery. The Arduino Uno converts the 12-volt source into 5 volts and distributes it to the components. Relay are used where it is necessary to control a circuit by an independent low power signal or where several circuits must be controlled by one signal. DC brushless water pumps uses to pump out any liquid, and it has a maximum voltage capacity of 12 volts and 4.8 watts. Infrared IR sensor beam infrared rays from the light emitting unit, and it's reflected from the surface of the object and absorbed at the light receiving unit. A potentiometer uses to control the water pump speed and the amount of the liquid. When the IR sensor detects an object, the IR sensor light turns on and sends a signal to the relay. When the relay or channeling module receives the signal, it transfers the signal to the DC brushless water pump and causes the water pumps to turn on. Due to the potentiometer, the speed of the water pump and the amount of sanitizing liquid can be controlled. And as you can see, this schematic diagram of the Arduino Uno or the circuit diagram of Arduino Uno. Next is the schematic diagram. This diagram shows the connection between a component Arduino Uno, water pump, relay, and proximity sensors. The Arduino Uno is connected to the 12 volts power source and converts into 5 volts output to supply the components. The water pump's positive wire is connected to the 5 volts pin in the Arduino Uno. The ground of the water pump connected the relay ground's pin or the ground. So, every time the relay receives a signal, it automatically transfers the voltage to the water pump. The proximity sensor PCC pin connected to the 5 volts pin of the Arduino Uno, and the ground pin of the proximity sensor is connected to the ground pin of the Arduino Uno, and also the Vout pin of the proximity sensor is connected to the pin 7 of the Arduino Uno. So every time the proximity sensor detects an object, it automatically sends a signal to the relay and transfers the voltage to the water pump. So as we can see in the picture 4, the schematic diagram of the DC brushless motor, relay and the IR proximity sensor. Next is the control system. As you saw in figure 5, non-contact temperature measurement enables the surface temperature of the body to be identified without a physical contact between the measurement object and temperature sensor. It is based on the optical analysis of the infrared radiations emitted by the measurement object. This radiation is focused through a lens on the detector, which translates it into an electrical signal. This can then be converted to an output size proportional to the object temperature by means of signal. So as we can see at figure 5, the connection between infrared temperature sensor and the I2 LCD. Next is we have the schematic diagram. This diagram shows the connection between components Arduino Uno infrared temperature sensor and the I2C LCD. The Arduino Uno is connected to the 12 volts power source and convert it into 5 volts output to supply the components. The infrared temperature sensor is connected to the 3.5 volts pin in the Arduino Uno and CSL and CDA pins of the infrared sensor connected to the A4 and A5 pins of the Arduino Uno. The I2 LCD is connected to the 5 volts pin of the Arduino Uno, and then the CSL and the CDA pins of this LCD connected to the A4 and A5 pins of the Arduino Uno, same with the infrared sensor. So as we can see, Figure 6 the schematic diagram of the infrared temperature sensor and I2C LCD. And then sa Figure 7, a combination of schematic diagram of automatic dispenser and temperature measurements. And then as we can see, in Figure 8, the actual graphic model of the hand sanitizer dispenser and non-contact temperature measurement. So lastly, the results. The automatic hand sanitizer device and contactless thermometer reduces the possibility of the infection's transmission. The component of automatic hand sanitizer are battery source, relay, DC brushless, water pump, potentiometer, IR proximity sensor, breadboard, and Arduino Uno. The device worked when hand placed in the proximity of the sensor. The sensor activated the pump and drew the potentiometer. The speed of the water pump and the amount of liquid can be controlled. When the IR detects infrared energy or object, the IR sensor lights turn on and send the signal to the relay. When channeling, module receives a signal. It transfers the signal to the DC brushless water pump and causes the water pump turn on and dispense designated amount of liquid. For the power supply of the device, it can easily replace batteries. The contactless thermometer identified body temperature of the measurement object by the temperature. It is based on the optical analysis of the infrared radiation emitted by the measurement object. This radiation is focused through a lens onto a detector, which translates it into electrical signal. This can be converted to an output size proportional to the object temperature by means of signal processing. When an object put under or before the sensor, it detects the bodily measurement and records the temperature and display in the LCD. So this is our research called hand sanitizer and non-contact temperature measurement, prepared by Elias Onjon, Peter Jan Gutierrez, Clarice Pavira, Jaylor Vallejo, and Jomal Bautista.